For our last section, Dan and I are going to walk through some potential product and system solutions.
The first product category we'll look at is split system heat pumps. Called a split system because the condenser coil and compressor are in one package, the outdoor unit, and the evaporator and fan are in another, the indoor unit. Refrigerant lines are then connected in the field to match the system together. These end up looking a lot like most ducted residential systems. Cooling-only versions of split systems can range in sizes larger than 100 tons. However, heat pump split systems are typically 20 tons or less. Applications best suited for split system heat pumps would be the light commercial space, small retail, small office, and classrooms. When designing with these systems, ambient minimums are a concern. Most split system heat pumps do not have cold climate capability, so the heating capacity will be reduced or even eliminated when ambient temperatures fall below 32 degrees. To help with this situation, dual and auxiliary fuel options are available from most manufacturers. These systems typically lend themselves well for electrification retrofits. The outside unit is typically in a location that is easily accessible, and new heat pump equipment will have a similar footprint. For the most part, owners and designers replace the line set, refrigerant specialties, and coil. Also worth noting, for any heat pump retrofit, the electrical feed supplying the heat pump should be checked to make sure it can handle the heat pump duty. Next, we'll look at another split system, variable refrigerant flow, or VRF. These systems are probably the most popular heat pump system on the market today. Their capacity per unit is typically less than 40 tons, but they can be linked together to form larger systems. Over the last 5 years, we've seen VRF applications grow in number. Some of the more popular are schools, offices, and any kind of mixed-use space. The flexibility of these systems with refrigerant pipes running through the building instead of ductwork make them a good candidate for a wide variety of applications. VRF also offers a lot of capability in terms of operation. Auxiliary fuel is possible with electric terminal heat, and most VRF manufacturers offer cold climate capability with heating operation well below 0 degrees. Another great feature within most VRF products is smart defrost control. There are a couple different ways this is accomplished by different manufacturers, but the end result is the unit goes through a defrost cycle, but some heat is still delivered to the zone to avoid occupant discomfort with cold supply air. VRF is an interesting retrofit opportunity, and the difficulty of that retrofit will be based on the existing system. If the building has no air conditioning and you're comparing various systems on ease of retrofit, VRF might rise to the top. Being able to run small refrigerant lines through the building is typically easier than running ductwork through the building. On the other hand, if you're replacing an existing cooling system, say a PTAC, RTU, or any hydronic system, it's likely easier to use a heat pump of the same style instead of retrofitting to VRF. Take a PTAC, for example. It would be much easier to swap that PTAC for a packaged terminal heat pump than going to VRF. One thing to note, with any distributed heating and cooling system, the ventilation system would need to be considered as well. If a dedicated outside air system is used, that too could be electrified with a heat pump.
All right, next we'll start to look at some packaged units. And first is rooftops. These are typically offered with heat pump capability 20 tons and under. Rooftop heat pumps are a great electrification package because the unit can handle all aspects of the system: heating, cooling, ventilation, and controls. Typical applications will be similar to current rooftop unit applications, so classrooms, warehouse, small office, and retail, just to name a few. A limiting factor for many RTU heat pumps is cold ambient operation. Most units cannot provide the needed heating capacities at or below 0 degrees. However, dual fuel is an option from most manufacturers. In terms of electrification retrofits, these units might be the easiest. Assuming you're retrofitting an existing RTU, heat pump RTUs are built on the exact same chassis as the standard units. So the physical replacement is swapping the units out. Unlike split systems, there are no line sets external to the unit, so that's not going to be a concern. However, standard rooftop units cannot be retrofitted with heat pump components, so the entire unit will need to be replaced. Again, with any heat pump retrofit, electrical service must be checked to make sure it can handle the heat pump duty. All right, next is packaged terminal heat pumps. These units are on the smaller scale, mainly because they're only serving the room they're located in. They're typically applied in hotels, high-rise residential, dorms, and long-term care facilities. For backup heat, auxiliary electric resistance is available from most manufacturers. However, cold climate heat pump is not a common feature for most packaged terminal heat pumps. Typical operation is going to be just based on the outside air temp. When the temperature goes below 32 degrees, the heat pump turns off and the electric resistance turns on. For cold climate locations, this means you'll be sizing your peak heating and electrical loads with 100% electric resistance. However, these products are ideal for electrification retrofits. If there is already an opening in the building that contains a PTAC, going with a packaged terminal heat pump with the same chassis is very doable. If the building you're looking to retrofit does not have air conditioning at all, cutting an opening in the side of the building to accommodate a packaged terminal heat pump might be a bit of a hurdle, but potentially a lot easier than other system options.
Water source heat pumps are probably the most well-known heat pump technology on the market today. Typically, sizes are less than 25 tons and can heat and cool multiple zones or single zones. They cover a wide variety of applications, some of the most common being apartments, offices, schools, and clinics. For electrification options, the system can offer multiple forms of dual fuel. The product itself can be supplied with electric resistance backup heaters. On top of that, the condenser loop can be tempered with either electric heat, heat pump heat, or gas-fired heat. This flexibility allows the system to operate in cold climates without issue. In terms of electrification, water source heat pumps have a lot to offer. Since all the heat pumps share a common condenser loop, heat recovery is maximized in the system. Any water source heat pump can provide heat recovery to any other water source heat pump on the system. For retrofit opportunities, water source heat pumps have two opposing categories. If you're looking to retrofit a building that has no air conditioning, water source heat pumps might be one of the hardest systems to get into the building. You need both a common water loop and terminal equipment run to each zone. This makes it quite restrictive. On the other hand, if you have a building that already has water source heat pumps and uses a gas-fired boiler for loop tempering, this offers a potential target for electrification. That boiler can be supplemented or replaced with a heat pump chiller or chiller heater. Since loop tempering can utilize mild hot water temps, air and water heat pump technology available today is well suited for this application. Before we leave water source heat pumps though, one more note on retrofits. Any hydronic system could be a potential retrofit opportunity for water source heat pumps. Since there are already water pipes running to each zone, they could potentially be repurposed as a water source heat pump condensing loop. Okay, that's it for unitary, packaged, and split heat pumps. Next, I'm going to take us through products on the applied side.